Okay, this video is going to go over solving for x in isosceles and equilateral triangles. I have 9 examples on here. I'm hoping that'll be enough to walk you through these. So basically what I want you to do again, pause it, try to solve the problem on your own. Then press play so you can see me walk through it, and hopefully that'll help you with all the rest of these here. So go ahead, pause it. Alright, so we know in isosceles triangle that these two sides are congruent, so it means the angles across from them are going to be congruent. So these are congruent. So therefore, since these two angles are congruent to each other, x is going to be the same as this angle, so 65. Go ahead and pause it. Alright, this one works the opposite of that first one. So in this case, these are both 70, so it means they're equal, right? That makes sense. So the sides across from them are also going to be equal. So it makes these two sides equal. So if one side's 4, the other side's got to be 4 too. Alright, here's one kind of like the first one. So these two sides are equal, right? So the angles across from them have to be equal. So it makes these equal to each other. Well, if those are equal, how do we solve for x? We set them equal to each other. That is supposed to be a 30. I'm really sorry that it doesn't really look like it. So if your answer doesn't match mine because these weren't written down like mine are, I apologize. So I'm going to subtract my 4x over and get x. Subtract my 30 over and get 8. Alright, for this one, those two angles are already equal, so that means the sides across from there are going to be equal. So if those two sides are equal, how do you solve for x? Well, you set them equal to each other. So subtract 3x over and get 4x. If I subtract 18 over, I get 12. Divide both sides by 4, so x equals 3. Alright, this one's meant to be a little bit tricky, but just keep the same ways that you were doing before. So these two angles are equal, so the sides across from them are equal. The 6 is down there to confuse you, okay? These two sides are equal. They have nothing to do with the bottom side, so just set these two equal to each other. So I'm going to subtract my 8x over, subtract my 3 over, and get 4. So divide both sides by 2, x equals 2. Alright, this one. These seem to confuse people a little bit, so I'm glad we're going to go over these. So those two sides are equal. It means the angles across from them are equal. Okay, so therefore, can x be 50 like up here? No, those two are not equal. You cannot say that. One thing we do know about triangles is that there's 180 degrees in a triangle, right? So if we take 180 minus 50, we get 130. So that means between these two angles, there's going to be 130 degrees between the two of them. But we know that they're equal to each other, so if we just divide that by 2, that'll give us our x, which is 65. Right, here's one very similar to the last one. So again, these two sides are equal, so the angles across from them are going to be equal. So you cannot set this one equal to 50. They're not equal. That's not okay. But, like we said, we know that we can take 180 minus 50 to get what's between those two. In this case, is 130. I know this example is kind of like the last one, but that doesn't really make a difference. So 130 degrees is what's going to be between these two sides. And we know that they're equal, so we can just divide that by 2. So 130 divided by 2 is 65. Now, these two angles are each 65. So is x 65? No, because this whole expression needs to equal 65. So we're going to go like this. Now we'll subtract 15 from both sides, get 5x equals 50. Divide both sides by 5, so x will equal 10. Alright, this one. Now we're into the equilateral triangle part, and you'll see why. So these two sides are equal, right? So that makes these two angles equal. Same logic as the last two. We can take 180 minus 60, which gives us 120. So that means between these two angles, there's 120 degrees. We can divide that by 2 because they're equal. It means they're each going to be 60 degrees. Now, if you remember, we talked about If all three angles are 60 degrees, it means it's equilateral, right? That also means if it's equiangular. If it's equiangular, it's also equilateral. So all of these sides are going to be equal to each other because technically you can point arrows at all of them. So these two are now equal to each other based on these little hashes, so we can just set them equal to each other. So x equals 3. Last slide. Same idea as the last one. So these two sides are equal, so we can say these angles are equal. Okay. There's a few ways you'd actually think about this one. You could think about it in the sense that this one's 60, so is this one. And if those are both 60, that gives you 120, and what's left for this one? Well, that's left for there to be 60. So you just say x is 60 right off the bat. The other way you could have looked at it was that all these sides are equal, right? So technically, instead of just having hashes here and here, we also could have had one here. And now it's equilateral, which also makes it equiangular. So all these angles would have been equal, which again makes them all 60 degrees.